share the screen, yes. And if I just sort of say a few words while the presentation is sort of coming up, I'm very conscious that I'm the only person speaking from outside the region, but what I'd like to do in the next sort of 10 minutes or so is to introduce a project that a number of colleagues and I are working on with a local company in Birmingham in the UK, RS Hydro. And it's an example of what we call a knowledge transfer project, where we have a research idea, a commercial idea that an academic team can sell to a local company. And in this particular case, the product that we've been working on with the company is a sensor to look at water quality problems in real time. If we could have the next slide, please. The background to this is that we had an ongoing sort of research project in Southeast Asia, and where we worked with a colleague at the University of Malaysia in Sabah, Sahana Harun, who was looking at water quality dynamics in catchments affected by oil palms development. And in this research, we were trialing the use of fluorescent spectroscopy to look at microbial contamination and to look at the impacts of both effluent from oil palm plantation mills and changes in land use characteristics. And we published 2 or 3 papers on that sort of work, where we were looking at lab analyses of water quality in rivers like the Kinabatangan River in Sabah. And at the same time, if we could have the next slide, please. At the same time, so colleagues and I were talking to the local company in Birmingham about some of the water quality problems that we had very close to home. And I think we can all recognise some of the problems that we see in our rivers, problems of sewage, problems of industrial effluent, and so on. And for the last for many years now, there's been a ongoing concern about the links between the sewerage infrastructure and rivers, and the company was interested in whether we could apply some of the research that we'd been doing in Southeast Asia closer to home. And if we could have the next slide, please. What we were very conscious of within the UK perspective is that there was a growing potential commercial market for a sensor, and that could reflect the concerns that were expressed by government, that could to work with some of our regulators in England, like the Environment Agency, the Scottish Environmental Protection Agency, Natural Resources Wales, that could reflect pressures that was coming through from governments, that was expressed in the Environmental Audit Committee, and could work with some of the quite key interest groups that we have, the key stakeholders in the UK, such as the Rivers Trust and the Canal and Rivers Trust, and other customers or potential customers for this product could include the water utilities as well. And the company, RS Hydro, were convinced that there was a viable market for a sensor if there was a confidence that the sensor would be able to characterize incidences of microbial pollution. We'd have the next slide. The next slide, please. And so over the course of 2 or 3 years, we had a research project with a company called a knowledge transfer project, or a KTP, where we developed the sensor that you see on the right-hand side, which was a multi-sensor probe that was looking at both the fluorescence of the water, electrical conductivity, pH, and temperature. And it was a sensor that was that could be used in real time, that we could calibrate and develop specific algorithms to ensure that we had confidence in the output that the sensor was yielding. If we could go to the next slide, please. So the probe that we developed through this project, it was a multi-probe. It looked at very specific wavelengths of light that were combined with other water quality parameters, such as temperature and turbidity. We had algorithms that were able to develop that were catchment specific, And we focus very much on one particular wavelength of light, tryptophan-like fluorescence, which we're able to associate with particularly sort of microbial pollution. And in the context of UK rivers, we were interested in sort of incidences of combined sewer overflows discharging to the river. So the inputs, also the parameters that were output from this sort of sensor, they were output in real time, including biogeochemical oxygen demand, chemical oxygen demand, and so coliforms and total organic carbon. And we can have the next slide then, please. And so I think the point's been made in some of the earlier talks about the needs to actually work with sort of stakeholders and the importance of actually from a company perspective in terms of generating sort of profits. And what we were able to do with this successful collaboration and sort of ongoing sort of collaboration, we're able to work with a company to ensure multiple sort of sales of this sort of sensor. The project itself won a Queen's Award for Innovation sort of last year. We are currently using this sort of sensor and testing this sort of sensor in Mali on a medical sort of project, and also in springs in the Indian Himalayas. And so there is a PhD student that's currently working there at the moment. We also have a follow-on KTP, a knowledge transfer project, that's looking at developing and testing an absorbance-based sort of sensor. And we are effectively sort of carrying out sort of ongoing sort of validations of the sensor output that you see in the two graphs here, that was looking at estimates of biogeochemical oxygen demand in sort of final effluent in the water treatment works and in the primary sort of settlement tank. So one of the aspirations, one of the hopes of this project is that we can secure more sort of sales and in terms of ensuring that operations for water treatment can be carried out more efficiently and more effectively. If we could have the next slide, please. And so my sort of last slide is really, I think this sort of project sort of demonstrates that or the benefit of having very flexible funding routes. We can provide evidence of successful collaboration globally between academic institutions and industry. And that's very important if we're trying to seek to encourage innovation. And innovation in whatever sort of level is fundamentally important if we're to achieve the key global goals that we're continually exercised about in terms of achieving sort of net zero and achieving the United Nations Sustainable Development Goals. I think our own experience of this particular project is that it's very useful to engage continuously with sort of industry and to have this sort of fruitful sort of collaboration to ensure from an academic perspective that we benefit from this, but from an industry sort of perspective, the key lessons that we're told is profit before tax. And so it's the idea of actually how they can sort of maximize sort of sensor sales and sort of ensure that the sensors fill a sort of niche in the marketplace. And what we're trying to encourage the business to do is to think more sort of globally at other markets. And finally, I'd suggest that we need policies to encourage project development beyond that sort of proof of concept. And so from my own sort of personal academic sort of perspective, we can be exercised and excited by academic sort of challenges, but it's really rewarding to see how we can take that on to the next sort of step and see an ultimately sort of final sort of product, a very specific sort of product sort of developed and used successfully. And if people are sort of interested, we have a number of papers that are sort of coming through at the moment, and I've just put one example there that was published recently in Water Science and Technology, where we describe the calibration of the sensor for biogeochemical oxygen demand. Okay, and I'll finish there. Thank you.